All right, so we're going to be talking about percent composition today. And before we start figuring out how to do the math, how to do the calculations, we want to have that basic understanding of what are we looking for with percent composition. So let's think about what we know about percents. Where you guys have probably seen percentage the most is in your grades, right? So think about a quiz. If you have a quiz that has 25 questions and you get 21 correct, how would you figure out what your percentage is? Well, you would take the ones you have correct, 21, divided by the total number, 25 total questions, and you would multiply by 100. So if you do this math out, you would get an 84%, okay? 84% correct, all right? Part out of whole times 100 is how you do percentage. We're going to think about what is composition now, okay? Composition, the root word that I see in here is compose. So if something's composed of something, what does that mean? It means that it's made up of something. So my t-shirt would be composed of cotton. The table might be composed of wood and metal. So what is it made up of? When we're talking about compounds, we're also going to figure out what are they composed of. So the most common compound we talk about, water, H2O, is composed of 2 hydrogens and 1 oxygen. But we're going to be able to calculate what percentage is hydrogen versus what percentage is composed of oxygen. All right, so we're going to be kind of looking at the masses to help us determine our mass percent, the percent composition by mass of each element in a compound. All right, so the first thing that we want to do is we want to figure out how much by mass do we have of each element. So we're going to write down our given information. A compound is formed when 9.03 grams of magnesium combines completely with 3.48 grams of nitrogen. So I know that I have 9.03 grams of magnesium, and I know that I have 3.48 grams of N. How do I know what my total compound is? Just add them together, okay? If I know what the mass of my magnesium is and the mass of my nitrogen is in the compound, we're going to add them together to figure out what the total mass of the compound is. So we're going to do 9.03 plus 3.48 grams, and I'm going to get 12.51 grams, there's a decimal there, total of the compound, okay? Remember that composition is going to be your part. Remember that answer is correct, is the part, over the whole, the total, which is the total number of questions, or here, the total mass of the compound, times 100. That's what mass percent is, all right? So right here, I've got my mass of just my magnesium. Let's divide it by my total mass, and then multiply by 100. Okay, same thing here. Nitrogen, mass of your nitrogen divided by the total mass of your compound, grams, times 100. What does that equal? All right, so take a minute and do those calculations. You should get 72.2% mg, and you should get 27.8, that's an 8, percent N. Okay, so you can actually look at these, and if you add 72.2 and 27.8, you should get a total of 100. So it should total 100%. If it doesn't total 100%, double check your math. You made a little mistake, okay? So you can always check to see, did you do it correctly? All right? So all we're doing, part over whole times 100, all right? That's how you find your percentage by composition, your mass percent of your compound, all right? All right, in this example, we're actually going to find the percent composition of each element. So we're going to find the percentage that's nitrogen, the percentage that's hydrogen, and the percentage that's oxygen. Something that's important to look at this one here is that there's actually 2 nitrogens, 4 hydrogens, and 3 oxygens. So this nitrogen appears twice. Okay, so what I want you to do is start by adding up the moles of nitrogen. So there's 2 moles of nitrogen, there's 4 moles of hydrogen, and there are 3 moles of oxygen, okay? So what that means is we have to do 2 moles times the molar mass, which is going to be 14.01, okay? And that's going to be the mass of the nitrogen in this compound, all right? So that'll be 28.02 grams. Here, 4 hydrogens is going to be 4 moles of H times 1.01, the molar mass of hydrogen, to get 4.04 grams of hydrogen. All right. Now my oxygens, I've got 3. So 3 times 16 grams per mole, all right? And that's going to be 48. So you have 48 grams are going to be attributed to the oxygen. Now, at this point, we're at the same place that we were in example 1. All we need to do is we need to add up and find our total. We have the grams of the part for each, but we need to find the total. So I'm going to do that up here in the corner. I'm going to do 28.02 plus 4.04. I'm going to do plus 48.0. That's an 8.0. And I'm going to get my total being 92.18. That's my total molar mass. Okay? So now what I'm going to do is I'm going to take the mass of my nitrogens divided by the total molar mass, 0.18, times 100. And that's going to be the percentage of nitrogen. All right? So the percentage of nitrogen ends up being 30.4%. Okay? So now what I would like you to do is I'd like you to divide by the total for both of these, for the hydrogens and for the oxygens. And I want you to find out what's the percentage of hydrogen and what's the percentage of oxygen in this example. All right? So you have to finish these. You finish. Okay? Make sure you show it in your notes. So what we're going to do for this third example is we're going to use information about the mass percent that we just calculated in example 2 to help us with example 3. So this time we have 125 grams of NH4NO3. And I want to know how much nitrogen is in that 125 gram sample. So what you need to know is you need to know your 30.4% nitrogen in this compound, which is what we got from example number 2. All right, so let's start out by writing our given over 1. Our given is 125 grams, and that's our sample, NH4NO3. Put that over 1. Sorry, it's a little messy. Okay, the next thing that we want to do is we want to figure out how do we use that to help us figure out just the mass of the nitrogen. Well, if you think about a percentage, it's out of 100. So for every 100 grams of this, there's going to be 30.4 grams of nitrogen. So I'm going to use that to help us. So I'm going to write 30.4 grams of nitrogen in every 100 grams of NH4NO3. And then if you look, my units are going to cancel out, and I'll be left over with grams of nitrogen. So if you do this math out, you're going to get that that equals 38.0 grams of nitrogen in a 125 gram sample. You can think about it doing this way, or some people just with percentages like to see it a different way. So you can think about your sample, 125 grams, and you're going to multiply it by the percentage in decimal form, which is 0.304% nitrogen equals. Okay, so you can think about doing it either way. Both are acceptable. People like different ways, okay? Both mathematically are the same and will both get you the same answer of 38.0 grams of nitrogen in the sample, all right? So that's our third way that we can think about percent composition, just a different way you might see it written in your examples, all right? Nice work.